So here we have a magnet with a magnetic field, and it looks like a donut. It comes out this way. It comes out of the end, comes back, circles around, and comes back in the back. This is just a battery with a couple of paper clips on it. And if I'm good enough to put wire through the loop.
It's like threading a needle.
Yeah, don't get old, guys.
Well, it beats the alternative.
Yeah, maybe.
That looks like magic.
I know.
And that's the current goes through the battery, goes to the coil, and when it does, it makes another magnetic field that is attracted to the magnet down below. And this is how your vacuum cleaner or electric drill or any electric motor you have works. Yeah. If I switch the motor, if I switch the magnet over,
way back when,
it might stay in the middle. But
the gentleman who invented the light bulb, Thomas Edison, had all the patents on DC motors. So he tried to make DC work for everything.
got it.
And Westinghouse had the patents for AC motors. Okay, so this is a simple DC motor. Turns out AC motors are more efficient, and
Instead of
AC
doing a
travels
YouTube
through
video.
wires more efficiently
How's that?
to get to your home.
Good.
So that's
Okay.
why we ended up with AC in the home, but Edison tried his hardest to make DC the standard.
Here are two more motors, and these motors are even simpler. They're called homopolar motors, and that's because they don't switch the polarity.
Homo means same.
So they don't switch polarity like this other motor does. And so we have, here's one that's good for Valentine's Day.
Pretty cool. How do you do?
And again, that's because the current is coming up through the wires, touching the magnet down below, and interacting with the magnetic field, and that's what makes it spin. There are all different kinds of shapes of those, so we've got that one, and let's hope this one works again. It kind of got mangled by the last class.
That works pretty well.
It looks like a light bulb.
And that one works better because it's touching the magnet in two places.
Yep, and it's a balance. This one, the reason this one goes slow is because it's actually self-regulating. As soon as the speed picks up, it breaks the contact at the bottom, so then it comes back down, touches again, and picks up
The
speed
moment it
again.
breaks contact, no more current flows.
Yep.
It's like a light switch in that regard.
So these are, you can get magnets a little smaller than this, but you can get an effective magnet at the hardware store.
But that's pretty fast, but is that the best you can do is?
Oh, no, we're gonna have the kids do the best one.
Yay! Yes!
But right now, I'm gonna show you other things you can do with it.
Okay, now, watch the compasses, guys.
I have to get the train. So I parked the train. We're gonna make the world's smallest electric train here.
What electric train?
Yeah, the only thing missing here is a Christmas tree in the middle.
What electric train?
You're gonna see it. You're gonna want to tape this.
Okay, so what'd you find? So here we've got two magnets stuck on the end of a AAA battery. And it's just in a coil of wire. And we put it inside. Wrong way. Okay. Put it in the coil of wire.
I think your battery needs to be,
Somebody did something. So,
we need a new battery here?
now let me see it. It's
You see the compass moving?
where that is.
I think a AA will work with those.
No, it has to be a AAA. I've got more, but the question is, oh, hey, this is probably why.
Batteries are
Yeah,
the
somebody.
magnets have to be the correct direction for the battery?
What,
Yeah. and I
what
think
is
somebody-
what is the tube for?
The tube is what makes it move.
So guys, you see how easy it is for science to not work? You have to know exactly what you're doing, and people would experiment, and all of a sudden something would work, and then something wouldn't.
So here's your, all it is just two magnets. It's shown like up there on the board with
Are
the
we
battery in
almost
the
done
middle.
with this?
And when you put it into the coil,
Nope. What happens if you connect the circle?
we do this.
Now watch these magnets as it goes by. And notice the closer the magnet gets, the more it wants to spin when the thing goes by.
How long are we done with this?
Yeah,
We're done
that
now?
is cool.
So that's, this works because the current coming out of the battery goes down through one magnet into the coil, makes the coil a magnet, and then comes back up through the other magnet. And these magnets, one of them is attracting to the back, one in the back is attracted to this coil magnet, and the one in the front is repelled by it, and that pushes it through the tube.
So
Are we
this
done
has
now?
to be coils of wire in order to work, right?
Yep, yep.
Because if it were just a copper pipe,
It can work in a,
I'll show them.
and outside the wire too. If you put two coils next to each other, you can lay the train on top, and it'll actually shuttle across the outside of the coils. So it goes slower.
like a
So it makes like a
levitating train.
station. So if you look on YouTube, you can see they make a pair of coils there, and when the train comes in,
Don't pull
it
that
slows
apart,
down.
because
Yeah. Okay, now I'm gonna have you make your own motors. Yes. And so everybody take one of those. Now, the rule is,